Okay, in this unit, as you can tell, this unit is basically about different ways of integrating messier and messier things that they could throw at you, meaning that this unit is basically so that they can make the test harder and give you more complicated things to integrate without using calculator or any other aids. So we talked about integration by parts, which is if you can't use substitution and you could do an ultraviolet thing and not get stuck, then yeah, just remember ultraviolet voodoo. But what if you're given something that looks like this? So your first reaction to this is probably, well, I can't, there's no basic algebraic way of doing this, meaning like any anti-power rule or anything like that. I can't use U substitution because the denominator, you would get 6x minus 2, and there's no 6x minus 2 in here, so you can't do that. And because of that, you can't do any kind of natural log U substitution thing. And I don't even know what I'd make my U and dv. It just doesn't even, there's more than two things in this kind of, there's actually, well not really, but there's nothing being multiplied together that would really work like that, so I'm kind of stuck until this video. Basically, this is kind of a pre-calc review, but you need to simplify this fraction into two separate fractions, and this only works if it's bottom heavy. If it's top heavy, you'd have to do synthetic division or long division to reduce it until it was something that would work. Um, but, well, this is kind of a pre-calc review. What you want to do is you want to you just simplify this into two separate integrals where, you guys remember this from pre-calc, then you get like a over 3x plus 4 plus, let me make sure I got this right, because I'm really bad at factoring in my head. Okay. Ooh, whoops. B over x minus 2. What we did here is because this factors, you could say that this 2x over that is, I know you can't see this right now, but that it would, you could factor this into that, and then there should be some two fractions that if you add together and then make the common denominators, you would get this. You guys remember how to do this in pre-calc then? You multiply both sides by this, so that you're left with 2x equals a times the opposite one, which is x minus 2, plus b 3x plus 4. And then, if you guys remember correctly, you could do a system of equations, but the easiest way is to just say, well, if x equals negative 4/3, because then that would make this equal 0, which would make b 0, and you can find out what a is. And I don't want to do all the work right now, so you would get that a is 4/5. And then if you said if x equals 2, because then you get 2 minus 2, which would make the a's cancel out, or get multiplied by 2, b does not equal 0, I don't know why I wrote that, b equals, I have no idea why I wrote that, 2/5. So the first thing you have to do is find out what these a's and b's would be. So now that we know that the a would be 4/5 and that b would be 2/5, then you can rewrite this integral into two separate fractions. So you get integral of, and I'll put it out in the front, so I would get, well, they have a common 1/5, so I'll do 1/5 times 4 over 3x plus 4 plus 2 over x minus 2 dx. I'm sorry, one sec. I thought my dad was talking to me, sorry. And then what you could also do then is split this into two separate integrals. So then you could do plus, and you could actually then pull this out. So it would be dx plus 2/5 1 over x minus 2 dx. And then you know how to do these. These are just natural logs. So you would get down here 4/5. Yeah. Okay, that was weird. Sorry. You get 4/5 times natural log of 3x plus 4, but you also have to think, well, if you did this derivative, you would get 3 over 3x plus 4, and you want to cancel that out, so you just get 4/5, so you then multiply this by 3, or 1/3, to get 4/15. That's just doing reverse chain rule. Plus 2/5 natural log of absolute value x minus 2 plus c. This right here is the antiderivative of that by doing partial fraction.